Okay, we wanted to do one of these. This is on the back of the page. It says congruent triangles. It would have been this is probably the fourth page in the packet. Um, if you kind of count pages as you're stapled together, if you're in the year 2015. All right, so one thing we got to do before we get going here is it would help us if we draw a picture of what it's telling us up there in the given information. Okay, so I see this CAS is congruent to LAT. So let me draw two triangles. It doesn't really, I'm just drawing something to be able to think with, so it doesn't really matter, what they look like. I'm just trying to say they're congruent, and they tell me that CAS is congruent to triangle LET. That means the first letter C is congruent to the first letter L, so L will go here. The second letter A is congruent to the second letter E, so I'll need to put E here. And then the last letter S is congruent to the last letter T, so it means T goes here. So I know these are congruent, and I've drawn them so they match up. Okay, I could mark them all up, but that's just going to make my figure look really cluttered. Those congruent statements tell us a lot of stuff, and we need to pay attention to them. And really, for this one, it's so helpful to draw it to figure out the rest of the work here. All right, now, if you're, again, I've covered up some stuff on my sheet, so you need to be looking at your worksheet, so I don't want to hear any complaints that you can't read it because I wrote over it on the iPad because, again, you're supposed to be working this on your sheet, right? All right, AS is right here. And if we know it's congruent to ET, they want to know what AS is, so I don't really have to worry about ET right now. AS is 13x minus 6. Let me go ahead and write information they give me on the figure. 13x minus 6. They tell me, oh, ET is 10x plus 21. It's a good thing they told me that because they want to know what x is, and I got to be able to figure out something to do to find x. And right now I can see I've got two pieces of information that are, they labeled sides that are congruent to each other. So right there I can write an equation. I can say 13x plus 6, oh no, 13x minus 6 is equal to 10x plus 21. Because those are congruent sides, therefore I can set these quantities equal to each other. Equal quantities can be made into an equation. I know we got to find x. Let me go ahead though and label here. I see that CS here is x squared plus 30. So let me go ahead and label that. This side right here is x squared plus 30. Okay, and that's really all the information I got there. Oh no, they do tell us, I don't think I got it. Yeah, here it is. The perimeter of LET is 322. So we've got the perimeter. Now if these are congruent triangles, isn't that the perimeter of each triangle? Since they're congruent, they're going to have the same perimeter. So 322 is the perimeter, and I could apply that to either triangle. All right, so let's go. We need to find x first. We'll worry about all the other information at another time. Okay. X is, I can use this equation here to solve for x. I'll write in black. I have x's on both sides, so let me move the 10x's over to the other side. If only the iPad would pick up. 13x minus 10x is 3x. 3x minus 6 is going to be 21. If I add 6 to both sides, 3x would be 21 plus 6 is 27. Okay, and since I'm short on room, I'm going to start leaving a few things out when I solve equations. And again, we want to get to where we're doing that anyway. If I divide both sides by 3, wouldn't x be 9? So I know what 9. I know 9 is x, so I can fill in that answer. Now they want to know what AS is. Now AS was 13x minus 6. So I'm going to go up just because I'm trying to think about how I'm going to have enough space to write on this figure. Here's 13x minus 6 up top. So 13x minus 6 would be AS, from looking right here, okay? But I know x is 9, so let me plug it in. 13 times 9 is 117, and so 117 minus 6, goodness, why won't it pick my hand up here? 117 minus 6 would be 111. So AS is 111, okay? Now they want to know what CS is. Well, CS is x squared plus 30, and I kind of had, a spot down here where I could work on it. So if you look down here, I've labeled x squared plus 30 down here. All I'm going to do now is go plug in x is 9, and that would be 9 squared plus 30, which would be 81 plus 30. If you put that in your calculator if you need to, 81 plus 30 would be 111 also. Write that down. Now, if CS, let's label some things that we've just found out. Let me use, I'll use kind of a dark green to label. I now know that CS is 111, and since it's congruent to LT, I know LT is 111. I know that AS is 111, and since it's congruent to ET, I know ET is 111. And I also know the perimeter of each of these triangles is 322. If they're congruent triangles, they have the same, perimeter. So now they want me to find LE, and you may go, well, they didn't tell me anything about LE. Well, they don't need to. We're trying to find this side. If I know that this triangle, LET, has a perimeter of 322, don't we find the perimeter by adding all the sides? So I could say 111 plus 111, well, so far that adds up to 222, right? But the whole perimeter is 322. So the only piece that's missing is that LE that they want to know. What if I just took that 322 and subtracted it from, 222 and subtracted it from 322? Oh, there's 100 left. That has to be how long LE is. So LE is 100. Now they say classify the triangle by sides. Do you notice that two sides are equal, like on LET? One side's 100, but there are two sides that are 111. When two sides are congruent, we call that isosceles, right? So when they're asking you to classify it by sides, if two sides are congruent, you're going to say isosceles. If three sides are all equal, that's equilateral. If none of the sides are equal, we call that, my brain just went blank, we call that oblique. An oblique triangle is one that all the sides are different, okay? So it's almost all your triangles are going to be oblique. It's special if they have two or three sides congruent. Those get special names of isosceles for 2 and equilateral for 3.